Hello. In the last presentation, we kind of redefined the sine, the cosine, and the tangent functions in a broader way, where we said if we have a unit circle and we define and we have and our theta is, or our angle is, let me use the right tool. Let's say, and our angle is the angle between, say, the x-axis and a radius in the unit circle, and this is our radius. And the point. The coordinate of the point where this radius intersects the unit circle is x comma y. Our new definition of the trig functions was that sine of theta is equal to the y coordinate, right? This is the y coordinate where it intersects the unit circle. And remember, this is the unit circle. It's not just any circle, which means it has a radius of 1. Cosine of theta is equal to the x coordinate of this point, right? This is the x coordinate. And tangent of theta equaled opposite over adjacent, or y over x. Equal y over x. And that's interesting because that's also equal to sine of theta over cosine of theta. I just threw that out. I wasn't even planning on covering that, but just it leaves you something to think about. So with that said, let's take a look, or let's try to see how this defines these functions. And I guess a good place to start is just with the sine function, and we can try to graph it. So let's do a little table like we always do when we define a function. Let's put in values of theta, and let's figure out what sine of theta is. So when theta is equal to 0 radians, what is sine of theta? So when theta is 0, right? Then the radius between it, the theta, this is the radius, and this is the point where the radius intersects the unit circle, and this point has a coordinate 1, 0, right? And so if where it intersects the unit circle is at 1, 0, then sine of theta is just the y coordinate, so sine of theta is 0. If we said what is sine of theta when theta is equal to pi over 2. So now our radius is this radius, and we intersect the unit circle right here at the point 0, 1. And what's the y coordinate at 0, 1? Well, it's 1. What happens when we have theta is equal to pi radians? So at pi radians, we intersect the unit circle right here, right? We're at pi radians. This is the angle, pi. Pi radians, we intersect this unit circle at -1, 0, right? Because once again, this is the unit circle. So at -1, 0, what's the y coordinate? Well, it's 0. So sine of pi is equal to 0. Let's just keep going around the circle. When we have the angle, when theta is equal to 3 pi over 4, right? Because it's, 3 pi over 2, right? Because this is pi, and this is another half pi, right? So this is 3 pi over 2, sorry. So when theta is equal to 3 pi over 2, what is sine of theta? Well, now we intersect the unit circle down here at the point 0, -1. So now sine of theta is equal to -1. And then if we go all the way around the circle to 2 pi radians, we're back at this point again. So sine of theta, so when we're at 2 pi, sine of theta is now 0 once again. So let's graph these points out, and then we'll try to figure out what the points in between look like, and I'll show you what the graph of a sine function is. Let's see. So let's draw the x-axis. This is my x-axis. And let's draw the y-axis. Not as clean as I wanted to draw it. This is y. And that's x. But in this case, instead of saying that's the x-axis, let's call that the theta axis, because we defined theta as the input, or our domains in terms of theta. So theta, this is the theta axis. And now we're going to graph sine of theta. So when we said when theta equals 0, sine of theta is equal to 0. So that's this point right here, 0, comma 0. When theta is equal to pi over 2, sine of theta is equal to 1. So this is the point pi over 2, comma 1. Right? That's just this one. When theta is equal to pi, sine of theta is 0 again. So this is the point pi, comma 0. And when theta equaled 3 pi over 2, let me write that, 3 pi over 2, I'll write it, 3 pi over 2. What was sine of theta? It equaled negative 1. Interesting. And then when we got to 2 pi, when we got to theta equal to 2 pi, sine of theta again equals 0. So we know that these points are on the graph of sine of theta. And if you actually tried the points in between, and I as an exercise, it might be interesting for you to do so. Either you could actually figure out a lot of the points using 30, 60, 90 triangles, or using the Pythagorean theorem. But you actually get a curve that looks something. Let me use a nicer color than this kind of drab gray. You get a graph that looks something like this. And you've probably seen that before. If you ever, it looks like a, I mean, the term for this function is actually a sine wave. It looks like something that's oscillating or that's moving up and down. And actually, if you were to put in thetas that were less than 0, the sine wave will keep going into the negative theta axis. And it keeps going forever in both directions. It keeps oscillating between 1 and negative 1 and the points in between. So that's the graph of the sine function. In the next module, I'll actually do the graph of the cosine function. Or actually, I might just show you the graph of the cosine function, and then I'll show you how they relate and how these can describe any kind of or many types of oscillatory, things in the world, and how it relates to frequency and amplitude. So I'll see you in the next module, and just for fun, you might want to sit down with a piece of paper and try to graph the cosine function or the tangent function as well. Have fun.